What's up, everyone? Welcome to our channel. Today we're diving into the world of software development to uncover what software architects do that programmers don't. Now, I know what some of you might be thinking. Aren't they kind of the same thing? Both write code, both build software, right? Well, yes and no. While there's definitely overlap, and many architects come from a programming background, the day-to-day focus and the scope of their responsibilities can be vastly different. It's like comparing the person who designs a skyscraper to the skilled craftspeople who actually build each floor. Think of programmers as the specialists who are incredibly skilled at constructing specific parts of a building. They lay the bricks, install the plumbing, wire the electricity, all with precision and expertise. They're deep in the code, solving complex algorithmic problems, implementing features, and making sure individual components work flawlessly. Their focus is often on the how to build this feature efficiently, how to fix this bug, how to optimize this particular piece of code. But then you have the software architect. Their view is much broader, more zoomed out. They're looking at the entire city block, not just one building, or in software terms, the entire system, not just one module. They're concerned with how all the different pieces fit together, the overall structure, the foundations, and ensuring the whole thing can stand the test of time and scale to meet future demands. It's a role that requires a different kind of thinking, a strategic mindset that goes beyond the immediate coding task. So stick around as we explore these crucial differences. The key role of a software architect is designing the overall system architecture. Before any code is written, the architect creates the master plan, the blueprint. They consider the entire ecosystem, not just individual features. How will services communicate? What are the major components? Without a solid design, you risk a tangled mess of code. The architect provides clarity and structure from the outset. They define the high-level organization, ensuring everyone understands the big picture. It's about laying a strong foundation. Identifying core functional and non-functional requirements is key. Performance, security, reliability, and scalability must be integrated from day one. Architects also define system boundaries and modularity. This allows different teams to work concurrently without conflicts. They communicate their vision clearly to all stakeholders. Architectural diagrams guide the development effort. Architects evaluate different architectural patterns and styles. They choose the best fit for the project's constraints. Overseeing implementation and evolution is also part of their role. The initial design is crucial, but it's an ongoing process. Architects ensure the system evolves effectively. Their work is essential for a successful project. Alright, so once that overall blueprint is taking shape, the next major area where software architects really shine is in making high-level design choices. This is where the rubber meets the road in terms of technology selection and foundational decisions that will impact the entire project lifecycle. We're talking about choosing the core technologies, the programming languages, the frameworks, the databases, and even the cloud platforms if it's a cloud-native application. These aren't trivial decisions. Think about it. Selecting a primary programming language, say Python versus Java versus Go, has massive implications. It affects the available talent pool, the performance characteristics of the application, the ecosystem of libraries and tools you can leverage, and even the long-term maintainability. An architect needs to weigh all these factors, considering the specific needs of the project and the strengths and weaknesses of each option. Similarly, choosing a web framework like React versus Angular versus Vue for the front end, or Spring Boot versus Django versus Express.js for the back end, shapes how developers will build user interfaces or APIs. Each framework comes with its own philosophy, its own learning curve, and its own set of trade-offs in terms of performance, scalability, and developer productivity. The architect is responsible for evaluating these trade-offs and making a call that aligns with the project's goals and the team's capabilities. And then there's the database. Will it be a relational database like PostgreSQL or MySQL, or a NoSQL database like MongoDB or Cassandra, or maybe a graph database or a time series database? The choice of data storage technology is absolutely critical because it directly impacts how data is structured, queried, and scaled. An architect needs to understand the data model, the expected transaction volume, consistency requirements, and future growth to make the right choice here. These high-level choices extend to things like messaging systems, Kafka versus RabbitMQ, caching strategies, Redis versus Memcache, and even the choice of cloud provider, AWS versus Azure versus GCP, and the specific services within those platforms. Each decision point is a branch in the road, and the architect is the one navigating, trying to pick the path that leads to the most successful outcome. One of the key skills here is the ability to see the bigger picture and understand the long-term consequences of these decisions. A programmer might be focused on implementing a feature using the chosen tech stack, but the architect is thinking about whether that tech stack will still be viable and supportable 5 or 10 years down the road. They're considering factors like vendor lock-in, community support, security vulnerabilities, and the overall cost of ownership. This often involves a lot of research, prototyping, and proof of concepts. An architect won't just pick a technology based on a blog post. They'll dive deeper, perhaps build small experiments to test assumptions, and evaluate how different technologies perform under specific conditions relevant to their project. Communicating these decisions and the rationale behind them is also a crucial part of the architect's role. They need to get buy-in from the development team and other stakeholders. If the team doesn't understand why a particular technology was chosen, or if they disagree strongly, it can lead to friction and reduced productivity. So the architect often acts as an educator and a persuader, explaining the benefits and trade-offs involved. Let's talk about two crucial aspects of software: scalability and performance. Architects play a pivotal role in ensuring these attributes at a system-wide level. Scalability is the system's ability to handle more work without performance degradation. This can mean scaling up resources or scaling out across multiple servers. Performance is about system responsiveness, including latency and throughput. Users expect fast, reliable applications. Architects design systems to meet these expectations, even under heavy load. They make careful design choices like using stateless services and caching layers. Load balancing and asynchronous processing also play key roles. So, another really significant area where software architects take the lead is in the integration of different systems and technologies. In today's software landscape, it's incredibly rare for an application to exist in a complete vacuum. Modern systems are often complex tapestries woven from various internal services, third-party APIs, legacy platforms, and diverse data sources. Getting all these disparate pieces to work together seamlessly is a major architectural challenge. Think about a typical e-commerce application. It might need to integrate with a payment gateway like Stripe or PayPal, a shipping provider's API like FedEx or UPS, a customer relationship management system, an inventory management system, and perhaps even social media platforms for authentication or marketing. Each of these systems might use different technologies, different data formats, and different communication protocols. The architect is the one who figures out how to bridge these gaps. This isn't just about writing a bit of glue code. It involves designing robust and resilient integration patterns. For example, how should services communicate? Should it be synchronous, one service calls another and waits for a response? Or asynchronous, one service sends a message and doesn't wait, allowing for more decoupling? Architects evaluate patterns like REST APIs, gRPC, message queues like Kafka or RabbitMQ, or even older methods like SOAP for specific integration needs. They also have to consider data transformation. System A might represent a customer's address in one format, while System B uses a completely different structure. The architect needs to define how data will be mapped and transformed as it flows between these systems, ensuring consistency and integrity. Security is another massive concern in system integration. When you're connecting to external services or allowing external services to connect to yours, you're potentially opening up new attack vectors. Architects are responsible for defining security protocols, authentication mechanisms like OAuth 2.0, authorization policies, and data encryption strategies to ensure that these integrations are secure and don't compromise the overall system. And what about reliability and error handling? What happens if a third-party API is down or responds with an error? The system shouldn't just crash. Finally, and this is a really important one that often gets overlooked when just talking about technical diagrams, software architects frequently take on significant leadership and mentorship roles. It's not just about drawing boxes and lines on a whiteboard. It's about guiding the team, sharing knowledge, and ensuring that the architectural vision is actually understood and implemented correctly. This human element is crucial. Architects often act as the technical authority on a project. When developers encounter complex technical challenges or are unsure about the best way to implement a particular feature in line with the architecture, they turn to the architect for guidance. The architect needs to be able to explain complex concepts clearly, provide sound technical advice, and help unblock the team. This requires not only deep technical expertise but also strong communication skills. They play a key role in translating the high-level architectural design into actionable tasks and guidelines for the development team. A beautiful architectural diagram is useless if programmers don't understand how to apply its principles in their day-to-day coding. So, architects often work closely with tech leads and senior developers to break down the architecture into manageable components and establish coding standards and best practices that align with the architectural goals. Mentorship is a huge part of this. Architects, typically being very experienced, have a wealth of knowledge to share. They mentor junior developers, helping them grow their skills and understand the why behind certain design decisions. They also mentor senior developers, perhaps guiding them in taking on more architectural responsibilities themselves or exploring new technologies. This helps build a stronger, more capable engineering team overall. This leadership isn't always about formal authority. It's often about influence and respect earned through technical competence and a collaborative approach. An effective architect can inspire the team to build high-quality software and foster a culture of technical excellence. They lead by example, championing good design principles and encouraging continuous learning and improvement within the team. So, as you can see, while both software architects and programmers are essential to building great software, their primary focus and responsibilities are quite distinct. Programmers are the masters of implementation, diving deep into the code to bring features to life with skill and precision. Architects, on the other hand, are the visionaries and planners, designing the blueprint, making critical high-level choices, and ensuring the system as a whole is robust, scalable, and maintainable. They're looking at that 30,000-foot view. It's not really about one role being better or more important than the other. It's about different skill sets and different areas of focus that are both absolutely critical for success. A brilliant architectural design is useless without skilled programmers to implement it, and even the best programmers can struggle if the underlying architecture is flawed. They work in synergy, and the best projects often have strong collaboration between these roles. Understanding these differences can help everyone appreciate the unique value each brings to the table. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more tech insights. We love diving into these topics and breaking them down. Let us know in the comments if there are other roles or concepts in the tech world you'd like us to explore. We'll catch you in the next one. Peace.